Dear students, subject is computer architecture and the topic is input output bus versus memory bus. Like how we can transfer our data from CPU to the memory and how we can fetch or retrieve the data from the peripheral devices, means the input output devices. Okay. So far we are just studying in this chapter how input and output devices communicates with the CPU, okay, and how further the data is transferred to the main memory. Okay, so here we need two types of buses. First is input output bus and another is memory bus. Okay, so far we have studied about the different types of buses, okay, and the commands generated by the CPU in our previous video. Okay, so here clearly you can see that this is the CPU, this is the interface. As I already mentioned you, interface we use just to communicate between the peripheral devices and the CPU. As the CPU is an electromagnetic device, so it can understand only the binary language, and our peripheral devices can understand only the analog in an analog language. So we need an interface to do the analog to digital conversion and further to digital to the analog conversion. Fine. So here we need an input output bus. Okay. In a previous video, the input output bus usually performs the three types of functions. The data lines are there, three types of buses. If you remember, we studied in the last video. Data bus is there, address bus is there, and our control bus is associated with this input output bus, which transfers the data, which provides the address of the bus, and which provides the control is basically done all the arithmetic logical units or operations basically performed into this control unit. Control bus. Address bus is usually used to refer the data to the particular register, okay, and data line is to send the data from the peripheral device to the CPU. And here we have introduced a new bus, which is a memory bus. Ultimately, when the processing is done into the CPU, it directs the data into the main memory or into the storage with the help of this memory bus. Fine. So like into our previous video, we learned about this data lines and address line, means data buses and address buses. In this video, we will learn more about a control bus. What exactly are the functions of this control bus? So here you can see that the control bus basically responsible for the timing signals. It indicates the validity of data and the address information. Means if we are sending a data, we will assign particular a time. Suppose a 2 milliseconds of time is particularly associated or given to a particular data. During this particular data, a data can have the approach to transfer from peripheral device to the CPU. If it travels within this time period, it's okay. If it's not possible for that particular data bits to travel into this particular time period, this time period will be expired and the next data bit will start the process of traveling from the peripheral device to the CPU. So this is the timing signal. Command signal, it specified operations to be performed, like which operation we have to perform, that will be done by the command signal. These all are the functions which are done by a control unit bus. Okay. Next is specific status signal. As we read in the previous video, that specific status signal, it mentions that whether our peripheral device is in the start state or not. Start state means whether all the wires and the data cables are properly connected or not connected. Typical control lines include memory write, like if you want to write anything into our memory, okay. If you want to just read, if you might have seen, if we'll open the MS Word option, MS Word, a Word document, into that you can see that we have the option of only read. Only read means we cannot do any sort of editing into that. If we want to edit anything into that document, MS document, MS Word file, so like we have to go for the write option and we have to fetch the file from the memory. In the same way is the input output write and input output read. It causes the data on data bus to be output to the addressed input output port, and the input output read causes data from the address input output to be placed onto the data bus. Okay, data bus will collect the data and will forwarded to the CPU. The operations will be performed into the ALU, and then the performed operations results will be mapped to the memory with the help of memory bus. And one thing more is there, like we have two types of, you can say that, organizations are available. Two types of organizations means the first one is isolated. Here you can see that, yeah, here it is, isolated input output organization, and the another one is memory mapped organization. This is the memory mapped organization, and this is the isolated input output organization. What exactly is in the isolated input organization? We have to use the different buses. Here we can see that peripherals will use different bus and the memory will use the different bus to communicate with the CPU. Okay, but if we'll see into the memory input output organization or memory mapped organization, memory and input output devices will share their buses. Okay, this is a data bus, address bus, and this is a control bus. They share the common bus. Like if you can see that the data line bus here is shared by this input output device, the same is shared by this memory also. Okay, so into the memory mapped organization, the buses are shared, but into the isolated word itself says that we have to use the different buses. They are isolated, means memory is not combined with input or output devices. They will use the different buses to communicate with the processor. Fine. So this is all what we are studying into computer architecture, the input output interfaces. Okay, this all is a functioning, like how input and output devices, peripheral devices, communicate with CPU with the help of interfaces and with the help of the buses, various buses. The buses can be of data bus, can be of address bus, and can be of your control bus. Thank you.